like that. Let's see here. So you said fractional exponents. Like I'm still not seeing those. I'm seeing same base dividing, same base multiplying, stuff like that. Like x cubed times x to the eighth, stuff like that.
Um, um, maybe we didn't do fractional exponents.
I mean, so a fractional exponent is like x to the 1/2 is the square root of x to the 1, or x to the 2/3 is the cube root of x squared.
Oh, yeah, that was the worksheet. Sorry, I don't have that.
Okay. I mean, these are not really, I mean, like we can do some of these, but like they also kind of apply to what we're doing here, like x to the 1/2 times x to the 1/4. You still add the exponents. You still like,
Okay.
so could you add these exponents for us, please?
So x to the power of 2/6.
No, you got to make the same denominator. So like 4 and 4.
Okay. Um, 3/4. Oh, yeah.
Right. And then this is where you might need to write this as the fourth root of x cubed, something like that.
Right, okay.
All right, so let's try another one here. Let's say it's x to the 5/2 over x to the 1/3 power. So when the bases are the same, you subtract the exponents.
Wait, so you subtract them like x to the power of
Yeah,
15/6
you
over.
subtract. Yeah, yes.
Okay. Mm, so x to the power of 13/6.
Okay, so uh, then it's like, how do you write this as, well, it's the sixth root of x to the 13.
Okay. Okay.
So is this the kind of stuff you're doing? I'm still not sure.
Um, we only had like a little bit of this.
Okay, so we can do some more stuff. I mean, we were doing this the other day, like, 3x to the power of 5. That's maybe too big here. Let's do 3x to the power of 4. So this exponent applies to both of these. Now, there's really ones here, so it would be 3 to the fourth, x to the fourth, right? That, like that. And then you'd have to know, well, what is 3 to the fourth? 3 to the fourth is 81.
Okay.
All right. So,
Right.
and that's why I'm wondering like where we're going, because the stuff in the second picture here that you sent, the polynomial stuff, is kind of related, but not completely related. Like it's like maybe this was just an intro to polynomials, and it's like, why are we spending all this time um, working on this stuff that, really isn't relevant?
Yeah.
All right, so let's try another one. Let's say it's 2xy to the fifth to the power of 3. Could you try simplifying this for us, please?
Yeah.
And we'll just kind of do half and half here. We'll do half exponents half.
So 8x to the third power, y to the 15th.
So we can kind of combine this with some other stuff we're doing. Like let's say it's x to the 2/3 power squared over x to the 1/5 power cubed. Okay.
Okay.
So this time you have an exponent to an exponent, so you're multiplying. And now as a reminder here, when you multiply by a whole number, you can make it whole number over 1.
Right. Um, is it x to the power of 11 over 15?
So so we've got x to the 4/3 over x to the 3/5, and then you said
Um, then I made the two exponents have the same denominator.
and so you say what was the result there?
X to the power of 11 over 15.
So this becomes, and if you had to write it the way, the 15th root of x to the 11th.
Right.
All right, so let me go look for some problems. Um, all right, so let's do I guess this would be an exponent expressions quiz. Right. So sometimes I just struggle here to like even find problems to give you. So let me just throw a few up here. And if we can get through all of these, we'll just move on to some other stuff.
Okay. So then y cubed over x squared.
Very good. Yeah. Okay. Let's try one more here.
Okay, 1 over 16 x to the power of 4 y to the power of 10.
Okay. Now there's way more complicated questions here. But I mean, that's kind of it. I mean, there's like, it's like, I don't know, how deep down this rabbit hole do you want to go in terms of like doing questions? Is it enough, or do you feel like we haven't done enough? What would be best? What would be best for you?
Um,
I've got some more questions that are more complicated. They're multiple choice. We could do a few more, or do you want to? I think we should do a few more just because the next ones aren't, there's really not that much there either. You know, you're just combining like terms and rewriting polynomials. And so maybe
yeah.
maybe give this a try. This is more like what you would see in a college course.
Mhm. Um, this one B.
Okay, very good. All right, let's do another one here. So it's like they just get extremely, complicated. Yeah, there's a lot to go on here. So yeah, just do the best you can here on this, and I'll
Okay. This one is a D.
Yes, it is. Yes, it is. And one of the things you can do with multiple choice, and you kind of get it down to, two answers maybe by looking at the coefficient, 5, 1/10. Well, good. You're doing great here. I guess we should move on. I don't know. Uh, do do you know what you're going to have next class? I mean, sometimes that's a better way to do this is to like preview something upcoming.
No, I don't know yet.
It's very good, very good.
We
Yeah.
haven't
So
really done anything like big in class, and he kind of really doesn't do homework.
now you know why you're in school for 180 days.
Yeah, right.
Like, I mean, you get to college and you're like, why did it take so long to
Yeah.
get here? Because you really can move through a lot. There's a lot that they put on you to do as well. So the next thing here is like combining like terms, multiplying, adding, and subtracting. So let's just look at a couple of things here, like 3x squared minus 4x plus 5x minus 2x squared plus 1. Can you tell me any of the like terms?
3x squared and negative 2x squared.
Yes.
And then,
Minus 4x plus 5x, that becomes 1x plus 1. And this is in descending order. This is considered standard form. Okay.
right, okay.
Um, what is the leading term? I don't know if you saw this in class, but I'll just throw that out there. Term means it's not just a number, there's a variable.
The one with the biggest exponent.
So it's 1x squared. 1x squared. What is the leading coefficient?
1x.
Just the one. The coefficient is a number.
Oh,
Okay.
okay.
What is the degree?
2.
2. Okay. Let's try something else here. So this one's a little bit more complicated. Let's go at 2x squared minus 3y times 4x plus 5y to the fifth. Will you attempt to FOIL this? I know it's a little bit more complicated than what you've been doing, but it'll help to illustrate some other things that I'm trying to show here. If you're able to do it. I think you can. I mean, this isn't overly complicated.
Okay.
Take your time. If you get some questions, please ask.
Okay. I have 8x cubed minus 17y squared.
Is that it?
Yes.
Okay, that's not good.
Oh.
Yeah. All right. So it's a FOIL problem. It's 2x squared times 4x. That's 8x cubed. That part was fine. But then you have to multiply the first and the last. So that's 10x squared y to the fifth.
Right.
The middle one is minus 12xy.
Okay.
Then it's minus 15y to the sixth.
Okay, I have that.
Okay, so there's nothing that can be combined here.
Oh. Okay.
So this is where it's more difficult. So it's a little bit harder to know, like, well, what is the leading term? What is the leading coefficient? I want to talk about degree. So we're going to look at each of these. I'm going to give you the degree, and we'll see if you can figure out how I came up with that. So this one is 3, 7, 2, and 6. Can you tell me how I came up with the degree?
You combine all the exponents.
Yes, you add them up. So occasionally you see a problem like this. Occasionally you see problems like this. So this would end up being the leading term.
Okay.
The leading coefficient is um, and then the degree is 7. Okay. All right, so
Okay.
just because I'm a little bit concerned about the foiling thing, let me throw another foil at you. Just to see where you're at. Let's go x cubed minus x to the minus 1 plus x to the minus 2. If you could give this a try, please.
Okay, yeah. Okay, I have x to the fifth power plus x squared minus x cubed minus 1.
Okay, let me just double check you here. So we got x squared plus x minus 1 um, minus x to the minus 1. So I got something a little bit different here. So when you multiply the x to the 3 times x to the minus 1, remember you're adding those exponents. That's where the x2 comes from. And I'll just write those here so you can see them. That maybe is unclear. So that's 3 minus 1. Then it's 3 minus 2. Then it's 1 minus 1. So that's x to the 0. And then the last one is 1 minus 2.
Right, okay.
So maybe you want like you subtracted and then yeah, that's why they got that. I mean, I'm not sure, but yeah, that's why we got some practice here. And so, whoa, that's really weird. Another thing that you could see, well, another type of problem you might see here, I'm gonna put this in front of you, is you might see something like this. You might see like 1 over x plus x squared times x minus 1 over x squared. This is another FOIL problem, but and you'll see this a lot in your calculus classes. You really often want to rewrite here. So your rewrite step is x to the minus 1 plus x squared, x minus x to the minus 2. And you can do them, you can do it either way. You can do the top way or the bottom way. Um, whatever is best for you.
Okay.
But give this a try, please.
Okay.
I apologize. I had to step away for a moment. So if you said anything I didn't hear.
Oh no, it's okay. Is it just one?
The final answer is just 1.
Yes.
Okay, let's take a I have not worked this out. So the first one is 1 for sure. It ends up being x to the 0, which is 1. But
Right.
when you do the next one, that is definitely not 1. Now maybe it cancels something out, but it ends up being minus x to the minus 1 minus 2 or x to the minus 3 power. Do you have that?
Yes.
Okay, that's good. Then we do the inner. So we have x 2 plus 1, so that's x cubed. These do not cancel, by the way. Maybe that's where you're going. Then you have the x2 minus 2, which is x to the 0, which is 1. So what I have here is it's 1 and 1. That's fine. 2. X to the minus 3 is 1 over x cubed plus x cubed.
Okay.
All right, now these are pretty tough. Like these aren't your standard FOIL problems, but they are kind of in the scope of this class, I guess, based on what you're sending me. I mean, they're like totally unreasonable. But let's do something a little bit easier. Let's say it's like minus 2x cubed times 5x to the fifth minus 3x squared plus 2. This is a distributive property problem. You have to take everything out, this thing on the outside, and distribute it into everything on the inside.
Okay. Um, 10x to the 15 power
Wait,
plus.
wait, we got an issue here. You're okay. So you're multiplying the numbers, right? -2 times 5 is -10.
Oh, I have -10. Sorry.
Okay, I heard 10. And then you're adding the exponents. So you may want to rework the rest of it. You're not multiplying the exponents. That's why this problem is a struggle, because you are multiplying the numbers, you are multiplying x times x, but you add the exponents when the bases are the same.
Okay.
These are just the rules to play by here.
Okay, so then -10x to the 8th power plus 6x to the 5th power minus 4x cubed.
Very good. Very good. So it's this is good. Let's see here. So the other ones you occasionally see here, you had a few. Let me actually move to some standardized pets problems here. Not standardized press. Just some multiple choice questions if I can find any. Um, yeah, like here's one. So the next type of problems are where you have to distribute the negative to everything on the right. It looks like you did a couple of these in class where, this negative goes to each of these. And I've been switching to saying it this way, change the signs. So whatever it was, like k to the fourth is positive, it becomes negative k to the fourth plus 2 plus 8k cubed. And then you combine like terms after you bring everything else down. This minus goes to a plus when you distribute it inside, if that matters. So will you try simplifying this for me, please? I'll look for some more questions here.
Okay. I have 7k to the fourth, plus 3k cubed plus 5k squared plus 10.
Good. And even better that you put it in standard form. That's even awesome. So what is the leading term? Sometimes called the power term.
7k to the fourth,
What is the leading coefficient?
7,
And what is the degree?
4.
You got it. Nicely done. Nicely done. Okay. Is there anything else you want to cover tonight? If not, we should probably stop here.
No, thank you.
Okay. Thank you for going.